Let's go over a problem for this week's discussion quiz. The goal is to find the derivative of this implicitly defined equation. So we're going to find dy dx. The first step is to take the derivative with respect to x on both sides. I'm going to note off to the side that even though we're finding dy dx, we can also denote this as y prime. So I'm going to use the y prime symbol when taking the derivative here. So starting with y, what is the derivative of y with respect to x? Well, that is simply what we call y prime. We then move on to the next term. This is tangent of xy. So we have a composition of two functions. That means we have to use the chain rule. And also, the composition itself is a product, so I'll have to use the product rule too. To start with, what is the derivative of just tangent? The derivative of tangent is secant squared. And that's secant squared of whatever is composed inside the function. But then by the chain rule, we have to multiply by the derivative of just xy. This is a product, so I'm going to use the product rule here. If we take the derivative of the first thing, which is x, with respect to x, we get 1, and then we simply copy down the y. To this, we leave the first term alone and then take the derivative of the second term, which gives us y prime. Moving on to this 3 is a constant, so its derivative is 0. I'm not going to write that here. I will simply put an equal sign and take the derivative of the right side of the equation. Starting with 4x, the derivative of 4x with respect to x is simply 4. We then move on to taking the derivative of cosecant of 5x. This is another composition of two functions, and therefore we have to use the chain rule. We start by using the derivative rule for cosecant, and then at the very end, we're going to multiply by the derivative of this 5x, which will give us 5. The derivative of cosecant is negative cosecant cotangent. So I'm actually going to go ahead and erase this plus sign and just switch it to a minus. And this is because the derivative of cosecant is cosecant of whatever is composed inside the function times cotangent. And the thing that's composed inside the function is 5x. By the chain rule, you then go back and look at this term here and multiply by its derivative, which means you multiply by 5. We are at our last term, which is y to the 5th. I can use the power rule to take the derivative of this piece, bring down the 5, copy down the y, subtract 1 from the exponent, and then again by the chain rule, you get y prime, because you have to multiply by the derivative of this y. So we are now done taking the derivative of both sides of the equation. The last part is to solve this equation for y prime. And on the other side of the equation, we'll express it in terms of just x's and y's. The strategy is to take every term that has a y prime and bring it to one side. I think I'll bring it to the left side. Things without y primes, I'll move to the other side of the equation. To do this first, I have to get rid of these parentheses, so I'm going to distribute this into both terms here. So if we write that out, on the left you have y prime plus, okay, we're now going to distribute. That is, this gets multiplied here and here. I'm going to write this as, I'll clean it up a little bit, like I don't need this 1. I'm going to write y secant squared xy. So y secant squared xy. Then when this gets multiplied here, I'm going to put that as x secant squared xy with the y prime at the end. So x secant squared xy with the y prime at the end. And on the other side of the equation, there's really not much to do. Perhaps I'll put this 5 first. Doesn't really matter too much. I'll write this as 4 minus 5 times cosecant 5x times cotangent 5x, and then I'll write the last part. It's the same thing, 5y to the 4th times y prime. Now that the parentheses are all gone, I'm going to subtract this over here, and at the same time I'll subtract this to the other side of the equation. So I'll actually mark that down. So what I'm doing in this step is I'm going to subtract this from both sides of the equation, and also subtract y secant squared xy. I'll subtract that from both sides of the equation. So these will cancel. These will cancel. What we have left over is the following. We have y prime. We then have, I'll put minus 5y to the fourth times y prime, and then this plus x secant squared xy y prime. On the right side of the equation, we have 4 minus 5 cosecant 5x, cotangent 5x, and then also this minus y secant squared xy. Y secant squared xy. I'll now factor out this y prime from every single term. So if we factor out the y prime, on the left, we get y prime. In parentheses, I'll put 1 minus 5y to the fourth, and then plus x secant squared xy. The right side of the equation is exactly the same. And finally, this minus y secant squared xy. We do this because this can now be divided to the other side of the equation with y prime by itself. Everything on the other side of the equation will only involve x and y, so that's the final answer. We have that y prime is equal to, and it's a fraction. The fraction is 4 minus 5 cosecant 5x cotangent 5x minus y secant squared xy, and this is all divided by, and that's going to be divided by this thing, which is 1 minus 5y to the fourth plus x secant squared xy. And this here is the final answer.